Now we are going to discuss clinical hematology, okay? One of the main department of the laboratory. In the clinical hematology departments, we are with blood cells. Okay, we're measuring, we have to know the structure of the blood cells, the function of cells. Also, we examine the cells under microscope, or we some chemicals in regarding to the hematologic disease. This examination under microscope or counting white blood cells to get diagnosis of infection disease or kind of blood cell cancer, leukemia, or to diagnose anemia, to monitor them. Clinical hematology are very important tests that we performing. Now let's get started with okay. We know that the total volume of the blood in adults about 5 to 6 liter. That means 7 to 8% of the body weight is blood. And you know from the previous lectures about 45% of the blood is cells, and 55% is the plasma, the fluidic portion of blood. It can be either plasma or serum, okay? And the main cells, you know, red cells, white cells, and platelets, which we are going to discuss today deeply. Okay, hematopoiesis, production of the blood of the blood cells, is known hematopoiesis, and this cell production begin in embryonic development in the yolk sac, as we see these diagrams. Okay, it started at the first week of the embryonic life, okay, and then it's progressed to the fetal liver, okay. It's switched with the liver started to produce blood cells, okay. As you see, it increases the production of the cells in the liver, and now decrease at the end of the birth, right? And spleen take during the fetal life, okay. Eventually, in bone marrow, it started to produce blood cells, okay, at the 4th or 5th months of the fetal life, and it's continued to produce at the end of each person. Okay, a lifelong production of the blood, hematopoiesis, occurring in the marrow. As you see, okay, the different portion of the bones here. It's at the beginning of the of life. Almost all the bones are producing blood cells. However, okay, once if we get older, okay, as you see, the vertebral and pelvis, okay, as you see here in the red or pinky, okay, and sternum and ribs, they continue lifelong, okay, but other of the bones, they stop to blood cells, okay. Now we are going to discuss each of them. As you see here, CD34 pluripotent stem cells. Also, you also can say stem cells. Okay, give rise to the earliest myeloid and lymphoid precursor that I am going to show you. Okay, and stem cells can repopulate bone marrow after injury or lethal radiation that we give some people exposed to the radiation therapeutic for therapeutic purposes. After radiation, after after injury, the bone marrow is able to repopulate the stem cells. Okay, myeloid progenitor. There are two progenitors, myeloid and progenitors, and myeloid progenitors differentiate into colony-forming cells of the erythroid, which produce erythrocytes, myeloid lineage, which produce platelets, monocytes, macrophage, eosinophil, basophil, and mast cells. And lymphoid progenitors give rise to produce T cells, or either T cells or B cells. Now, as you see here, these diagrams is really good to explain the hematopoiesis. As you see, undifferentiated pluripotent stem cells, or you can say CD34 plus stem cells. Okay, this is as the other rest of the cells will produce from these guys. After differentiation, they become a progenitors, the myeloid stem cells and stem cells first. These all are occurring in the bone marrow, and then myeloid stem cells is going to differentiate to megakaryocytes to produce platelets, granulocytes to produce granulocytes such as basophil, eosinophil, and neutrophil, and erythrocyte precursor, which result in production of the erythrocytes, and monocytes, which end up with monocytes. And the second progenitors, the lymphoid stem cells, they differentiate to either B lymphocytes or T lymphocytes. Okay, now I'm going to talk about each step by step today and tomorrow. Now let's start with the of the erythrocytes and the structure of the erythrocytes and the function of the erythrocytes is really, really important. As okay, on these diagrams, okay, in the erythrocytes, maybe 99% of content of the erythrocytes is hemoglobin. a protein. Okay, the main function of the erythrocytes to carry oxygen to the of the body. Okay, it takes oxygen from lung and transport it to the each single cells in our body. Okay. Now, oxygen is transported in a combination with, right? And the concentration of hemoglobin in the blood is a measure of its capacity to carry oxygen. Therefore, hemoglobin measurement is the most common measurements in hematology. Okay, if you see some patient, okay, you almost request a measurement of the hemoglobin. Hemoglobin, okay, carry oxygen, and it's important to know the concentration of the hemoglobin. Now, hemoglobin, it's combined with the oxygen. Okay, I'm going to show you later. And the combination of heme, okay, heme which include porphyrin and iron and globin. As you see here, there are here two different structure. Okay, these are globin for change, polypeptide change, and heme for heme. Now, I'm going to show you maybe in a few slides the structure of hemoglobin again. Okay, the red blood cells, okay, the production of red blood cells begin in the bone marrow from stem cells, okay, from erythroid stem cells. And as you see in pictures at the bottom of the slides, okay, as the cell matures in the bone marrow, its diameter decreases, right? Nucleus becomes denser, as you see the diameter of the nucleus, the size of the nucleus, become denser and smaller, and finally release from the cells, as you see here, which is also known to become a biconcave disc. Okay, here, okay, just before it enters into the circulation, the last form of the cells is reticulocytes, okay, which is unnucleated. Okay, there is no in the reticulocytes, and then they will differentiate to become a erythrocytes. Okay, biconcave disc-shaped cells, red blood cells. Now, reticulocytes differ morphologically from the mature red blood cell because they contain a fine basophilic reticulum or network of the RNA and cytoplasmic remnant that decrease as the cells matures. And the red blood cells have a total lifespan of about 120 days. And the bone marrow release and leave cells into the circulation evidence. Okay, and the concentration of the red blood cells and the measurement of the effect of the volume of the red blood cells, which we call microhematocrit, are important laboratory measurements for the detection of the anemia, okay, or the overproduction of red blood cells. Okay, we are going to measure the concentration of the red blood cells, the number of the red blood cells, and measurements of the PEC value. Okay, we show us the percentage of the cells in the total bloods, and these are really to diagnose or overproduction of cells. Okay, any questions so far? Okay. Okay, as I said, red cells are formed in the bone marrow. Cells release in circulating blood after they mature. As the cell wear out at the end of their life, the reticuloendothelial system, such as spleen, they break down cells, okay, and the protein part of the cell goes into the proteins, into the amino acid pools, which can be used again in the bone marrow to produce new cells. And the iron part of the erythrocytes of the hemoglobin is recycled into an iron storage to be reused in the bone marrow, and the waste of the erythrocyte, which is a breakdown of the porphyrin ring, are excreted in the of bile in the urine and now, okay, this diagram explain what I already shared with you. The red blood cells in the circulating, once they wears out, at the end of their life, after 100 days, they will break down via reticuloendothelial system. Protein part goes to protein pool, amino acid pools. The waste product is converted to bile and excreted via either urine and feces, and iron goes to iron storage reuse. Now, let's introduce the structure of the hemoglobin. Okay, the more content of the erythrocyte hemoglobin. As you see in these two diagrams, two different pictures, hemoglobin consists of two structures, are heme, okay, and globin. As you see here is the ball shape proteins amino acid change, okay? There are 4 peptide changes in the globin, 2 in the adults, 2 beta change, alpha changes. Okay, now heme consists of 4 porphyrin rings and 1 iron molecule. Okay, now, and here you see 1 porphyrin, 2 porphyrin, 3 porphyrin, and 4 porphyrin rings. They attach to each other via iron atom. Okay, iron is really important. That means, if you don't take enough iron, that means the production of the hemoglobin will decrease, which result in anemia. Okay, therefore, you should have enough iron in your diets. Okay. It says here Adam, but it is not my production. Okay. What happens when the erythrocytes wear out after 120 days? Okay, as I said, reticuloendothelial system, such as lymphoid nodes and spleen, and there are leukocytes, macrophage, phagocyte, these older erythrocytes, and break down these into their components. And the hemoglobin will break down to make globin, okay, and porphyrin, and the iron is combined with the transferrin. Transferrin is a transport protein of the iron, and then take this iron into the bone marrow. Okay. So the other part of the heme was porphyrin, which consists 4 ring. This porphyrin is converted to the bilirubin, okay, and this bilirubin is combined with albumin in the blood circulation, so into as you see here, a unconjugated bilirubin, okay, which produced in the reticuloendothelial system, is transferred to the liver, albumin, okay. In the liver, the unconjugated bilirubin, okay, converted to conjugated bilirubin, okay, glucuronic combined with bilirubin via glucuronyl transferase enzyme, as we discussed yesterday, and this insoluble bilirubin become a soluble. Okay, now it is able to circulate via blood, and then this conjugated bilirubin is excreted either via kidneys, okay, as a urobilinogen, or via feces, okay, as a stercobilinogen, okay. The color of the feces, it gives from the bilinogens, okay. Now it is your time to give an answer to these questions. Blood cells production, which is also known hematopoiesis in adults, take place in which of the structure, which of the organ? Now I am going to drink my coffee and wait for your responses. Go ahead, please. Send your response. Hey, Imani. Don't be afraid. It doesn't matter whether it's or not. No, I want to get at least 3 results. I'm not sure whether you find the screen. Okay, the blood cell production, which is hematopoiesis in adults, placed in bone marrow. Okay, in the yolk cell liver, they produce blood cells, during the development in the fetal life, okay, before the birth, okay, which we call prenatal um, stage, okay. The correct answer is D, okay. But I want to thank you to you guys who sent the answer, okay. It doesn't matter whether it's correct or not. Now we are going to learn this, the next one. Which of the following cells is not differentiated from myeloid progenitors? Okay. T cells, erythrocytes, platelets, neutrophil. Okay. If you pay attention, for the stem cell differentiate into cells, cells and lymphoid cells, right? Okay, let's see. Okay, T cells is correct one because it's differentiate from the myeloid progenitors. Okay, good. Still waiting for the responses, all of your responses. Okay. Now let's see here. A heme consists of which of two structure? Heme and globin, porphyrin rings, iron, polypeptide chains and iron, bilirubin and iron, none of the above. I see your facial expression, whether happy or sad. Oh, sad? No, 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 no. Okay. Okay, porphyrin rings and iron is the correct answer. Okay, you have to know the structure of the hemoglobin, the function of it, okay, and the structure of erythrocytes. Okay, this is your duties. Now I am going to send them again and again. Okay, and then now we still continue with the hemoglobin synthesis, structure, and function. Okay, as I said, heme consists of iron and porphyrin rings, okay? And each hemoglobin molecule has 4 heme, 1, 2, 3, and a globin moiety, which consists of 4 polypeptide chain, okay? And because the heme molecule is a porphyrin, a group of disease called result from certain disorder of the heme synthesis. Okay? A disorder of the porphyrin is non-porphyria. Okay, is excreted from the body as a bilirubin. The the waste, okay, of the heme is the bilirubin. Okay, and globin, the second part of the hemoglobin, okay, consists of the 4 polypeptide chains, okay, and structural abnormality of the globin proteins known as hemoglobinopathy, okay, and underproduct of the globin is known thalassemia. You know, these two are most common diseases, okay, in terms of the pathology, hemoglobinopathy such as sickle cell anemia, and thalassemia is about underproduction of the globin. Okay, thalassemia A, B. Okay, there are different type of the thalassemia. Okay, it's common in Europe. Okay, now let's talk about the function of the hemoglobin. As I mentioned a little, the structure of it. Okay, now you see the molecular structure of the hemoglobin, and in the center of the porphyrin ring, the iron atom, okay, and the molecular oxygen will bind to the iron in order to transport oxygen from lung to the tissue. Okay, if which we call anemia, okay, because hemoglobin is not formed enough, okay. In order to produce enough hemoglobin, you have to have enough amount of the iron, okay. For each molecule of the heme, okay, we have this one molecular one atom of the iron, okay. Molecule fully saturated oxygen, okay. As you see, each hemoglobin is able to bind 4 molecular oxygen, okay. If it's saturated with oxygen, is non-oxyhemoglobin, okay. One released hemoglobin and bind carbon dioxide, CO2, okay. One is released oxygen, is now deoxyhemoglobin, hemoglobin without oxygen, okay. Now you see the green ball, iron, okay. It is really important part of the hemoglobin, okay. What's up? Come here. Okay, there are variants of hemoglobins. If you compare with the normal hemoglobins, okay, hemoglobin variants differ in the content and the sequence of acids, and also in the function of the hemoglobins, okay. In the normal hemoglobins, we have hemoglobin A or A2, okay, as a polypeptide change, okay. You may and hemoglobin F, the major form of intrauterine life, okay. The mostly hemoglobin F you see in intrauterine life, but after the birth, it will replace hemoglobin A. Okay,